All right, and our third category of compounds are acids. And acids are combinations of H plus and some anion. And since the H plus is going to be the same for all of these, the only difference is the anion. And so we just need to remember our anion names. For example, this is chloride. This is chlorite. And this, sorry, we need 2 oxygens for that. And this is chlorate. We're going to see all polyatomic, or all anions will end with one of these 3, ide, ite, or ate. And so we just need to look at our anion and determine what the name of the anion is, and from there we'll be able to name the acid. So for ide endings, we're going to call it hydroic acid, where the non-ide part of your name goes in that blank. For example, Cl-, which is chloride. If we were to make it into HCl, don't forget the aqueous, we're going to take that ide away, and that chlor is going to go in there. Therefore, this is hydrochloric acid. So, pretty easy. Remove the ending, stick it in the formula. Another one, how about with iodine? For example, that would be HI. You just put as many H's as are necessary to balance the charge. That's iodide. So we get rid of the ide ending, put everything else in that blank. This is called hydroiodic acid. All right, so fairly straightforward. As long as you can identify the name of your ion, your anion, naming these is not too bad. How about ite endings? For example, nitrite. We will see we have another formula here. We're going to remove the ending and call it us acid. So for example, HNO2, putting that H plus on there to balance out the nitrite, we get rid of the ite, put everything else in the blank, nitrous acid. Not nitrous oxide, no laughing gas here. Nitrous acid. Or we can say, for example, we have bromite. Again, we're going to get rid of that ite and add OUS acid, bromous acid, once we add that H plus on there. Not too bad. There are 2 special cases that will also take place in our 8 endings. We'll see that phosphite, and sulfite do not necessarily, they have slightly changed names. So we don't say phosphorus acid and sulfurous acid, but phosphorus acid and sulfurous acid. So we change those a little bit. This one is phosphorus acid. And the worst part is phosphorus, the element, does not have that OUS, just US. But phosphorus acid does have the O in there. So make sure you pay attention to the spelling there. And then we have here sulfurous acid. Sulfurous acid. So it's not sulfurous acid and phosphorus acid, but phosphorus and sulfurous. So those two are the only exceptions. So you'll want to be familiar with those. And lastly, we have our 8 acids. And these are perhaps the easiest ones, and one of the more common ones. We have, for example, acetate. We're going to see what we do is we drop the ending and add ic acid. So again, we're going to get rid of, I need to put the aqueous up here, don't let me forget that. No hydro this time. So we're not going to say hydroacetic acid, just acetic acid. So we get rid of the 8, put everything else in there. So the ACET, acetic acid. And of course the formula for that is going to be, put the H in front. Remember, all our acids are going to start with H, and we're going to see that, although this is organic chemistry, only that one H is acidic. The other H's don't participate in any acid chemistry. All right, another one, how about chromate? Let's figure out what chromic acid is. So it has the ic acid ending, which means it came from an 8, which means it came from chromate, which is CrO4 2-. Again, very helpful to memorize those polyatomic ions. We just need to put enough H plus to balance this out. So we'll need 2 of them. Since there's a 2- charge, each hydrogen is 1+. We'll have that be our example there. Just like before, the phosphorus and sulfur are a little weird. For phosphate and sulfate, our H3PO4 and our H2SO4 have the special names. This is phosphoric acid, and then sulfuric acid. So again, they're not phosphoric acid and sulfic acid, but phosphoric and sulfuric acid. All right, so that's our naming. I just want to throw out a few more common things. Common molecules. There's just a couple. Perhaps this one you've seen before. Technically speaking, we don't generally refer to hydrogen molecules under molecular names. We actually usually give them ionic names. For example, HCl without the aqueous is hydrogen chloride, not hydrogen monochloride. H2S is hydrogen sulfide. And as you can see, we follow ionic naming rules here. And so don't say dihydrogen monoxide. Unfortunately, that's not the systematic way to name this. Although hydrogen is a non-metal, we don't ever say dihydrogen monosulfide. H2S, by the way, is the rotten egg smell. Or we don't say hydrogen monochloride either. Because hydrogen, when it's combined with a non-metal, can only be H+. So we don't really say that. So better to say hydrogen oxide. Or really blow your friends away and call it hydroxic acid. Or hydrohydroxic acid. See if you can figure out where these names came from. Hydrohydroxic acid. That's H plus and OH minus. This one is H plus and O2 minus. Fun stuff here. So you can just call it water. Easier. Couple other ones you'll want to know. This is ammonia. This one is methane. Those are kind of other very common ones that we're going to see that we don't use systematic names for. So water, ammonia, and methane. We don't say carbon tetrahydride or something like that. We just say methane. So you'll want to be familiar with those. All right, so that's naming. And actually, that's it for this chapter. So in our next chapter, we're going to study a little bit more about kind of quantifying these compounds, as well as we'll start learning some reactions. So we'll look forward to that.